Hello, good morning, good afternoon, and good evening, everyone. Welcome to the IBM Developer Online Meetup. Thank you all for joining us today for our special event. I know we have people streaming from all around the world, and I'm so excited because today we have a really great partner. We have an awesome speaker from DataStax joining us today for today's webinar, where we're going to be diving deeper into how we can use DataStax built on Apache Cassandra to analyze real-time changes in clickstream data for e-commerce and retail-based applications. So my name is Pooja Mistry. I am a developer advocate here at IBM, and I'm joined by amazing speakers. Today we have Patrick Callahan, who is a VP and a partner CTO at DataStax, and also our very own Mark Sturdivant, who is a software developer and a developer advocate here at IBM. It's so great to have you both, Patrick and Mark. And I think today's going to be a really great session. Do you guys wanted to say anything, introduce yourselves at all?
I'll just say a quick hello. My name is Patrick. I'm from Dublin, Ireland, developer and architect for the last 20 years with DataStax the last 8. Looking to work with some great retailers. So looking forward to the session today.
Yeah. Mark?
I'm Mark Sturdivant. I'm one of the developers behind developer.ibm.com, and I got a chance to do some work with DataStax and Cassandra, so I'm glad to get a chance to walk you through some of what we did.
Awesome. Yeah, so before we get started, let's just get through a couple of guidelines. So if you're on Crowdcast or any other stream, feel free to use a chat to say hi and discuss topics relevant to the session. If you have any questions, please post them in a Ask a Question section, which is on Crowdcast, and we'll address these as we go through. And also, I wanted to let everyone know that this meetup is recorded, so you'll have this replay available immediately as soon as the event ends. So with that said, thank you all. And I'm going to just kick it off to Patrick to get started. So we'll go from there.
Thank you, Pooja. So as I said, my name is Patrick. I'm going to be talking about Apache Cassandra mostly today. And as we think about, the state of the retail industry today, I think, a couple of years have gone by that have been trying for everyone. And the retail industry has had a lot of ups and downs. In the last year or two, there's been a lot of companies that have found it very difficult. And that's not just because of the move to online, but it's also around the innovators and the new customer experiences that retailers are trying to build into their brands and their loyalty programs. And if we look at some of the great examples of, companies that are doing really well, and we think about a company like ASOS, who deliver an exceptional customer experience. And that's from the personal experience on their website to yearly delivery subscriptions and a free return service. Their whole process is focused on making it incredibly simple for a customer to engage with them. But customers also want to have that in-store experience. So retail in particular around clothing, 80% is still done in store. So then we look at other companies that we work with, especially a company like Burberry, who are changing what it means to interact with their customers. Burberry's social retail store in China is a place of discovery that connects and rewards customers as they explore online and in store. So you can imagine going into a store like this and swiping your phone as you walk in the door, and that obviously brings up some details around you. It also helps you to create some brand awareness and understand, increase your loyalty. But then you can use your phone to interact with the actual products themselves. You can see is your size available in different products? Are there different colors available that may not be in this shop? We also think about personal assistance. There is always that that idea of you want your retail stores and the places you visit to know who you are, that interaction and that customization of who you are is always great for brand loyalty. And you can imagine this going on in any retail store. And maybe it's inside the dressing rooms themselves. You can watch and look at different items that you may want the assistant to bring you. And then you can finish and check out without even having to go to the checkout line. So all these things are coming together in a different way that retailers are proposing to their customers. And at DataStax, we're very lucky to work with a number of customers that are retail customers that are building these type of innovations. And what it means is that they have to take data from a lot of different places. And when you think about the customer interactions, and Mark will get into them a little bit later, but understanding our customers better, understanding what they're looking for and how they're interacting with us, but also around things like personalization and things like orders and inventory and things like supply chain. How easy is it to get the products that our customers want in a timely manner? So as I said, we're very lucky to work with these type of companies, especially companies like Home Depot who've done the curbside pickup in the last couple of years to overcome some of the limitations around COVID and the challenges they've faced. But all these customers, all these retailers, are building innovations into their systems that don't just use their products and their catalogs, but also the customer interactions that they have and understand, so they can build a better customer experience. So think about from the coming into a store and they swipe their phone or they touch a brand loyalty card or something like that. And what happens is a holistic view can be created of that person in real time. Now, this may have been just before they left the office to go on their lunch break to walk into the store, or it could have been the day before they were using the internet to browse something they might look at the weekend. But what they're given is a view, a personalized view of who that person is and how they usually interact with your brand. Now you can see here there's information that just may be, is the person local? Is the person, does the person usually shop in store or online? Or how many loyalty points do they have? Or maybe it's even a preference of tea or coffee. What it also shows is the recently viewed items and things like that, products that they may have put in their basket but not actually checked out. So now we can start to build an idea of what this person may actually be in this shop for. We can also see recommendations and accessories of things that they have already bought. And this may help to hone down or focus on certain areas where the customer may be interested in. We can also see the recently bought items, which may be something that they may be coming in for an accessory for. And we can also tap into the store's inventory to see if the item is actually in stock in this store. And we may also see if the product is available in that size. So we can offer the customer a real-time experience that's based on what they're actually focused on when they walk into the store. Now, this type of view is exactly what is driving the best customer experiences in the industry. And this allows both assistants and online processes to offer the best experience to their customers. And the key aspect of this is the integration of customer experiences or customer interactions, their preferences, the retailer's products and inventory. So how do we enable all this? Well, if we think about this from a technical point of view, this dashboard is populated from tens, maybe even more, 15, 20 microservices across the platform. So if we think about that from the microservice point of view, you can see on the left-hand side here, there may be customer profile microservices, and they may be in GCP, they may use document APIs to interact and so on. But you want to be able to have the agility to have different microservices that live on different clouds or on-premise. You want to be able to bring that data all together in a very coherent way to a visualization like this to give that that full customer experience. So you can think about the different sides here. You can see that REST is being used. GraphQL is obviously becoming more popular, and REST is obviously the most commonly used. One thing that we have to think about as we think about how do we get all this data together, we think about how do we also make this scale. And when we think about scaling, we have to think about global scale. If you're a Gap brand or you're a Levi's or anybody, we're thinking about a global mission to bring the best customer experience to our customers. So we need data, and we need data at the right time to make the right decision. Now, data in itself is not enough, right? What we actually need is contextual data at the right time. Now, just a little, the nuance here is a little bit, I think it's worth having a little example. So if we think about a piece of data, so this here is the location of a vehicle. Now that in itself doesn't give us much information. We can't actually do something with this. What we need is that piece of data in context with all the data that's come before. Now, it may be a window of data like the last 10 seconds, the last minute, the last hour, and so on. But what that does is it allows us to create insights from that contextual data. Now we've been able to think about, well, now I know what speed the vehicle is going in. I know what direction the vehicle is going in. I know the time it will take to get to a certain location. And I also know if it's accelerating or decelerating. And if I enrich this even more with traffic data or weather data, then I can make a better informed choice. The more data that I have in context creates a richer outcome that I can drive. So that's just the idea of contextual data that I think is important as we go on. And we'll talk just a bit about Apache Cassandra, because this is one of the reasons why customers like Walmart and Home Depot have been able to use that, have been able to drive better customer experiences. And we think about Cassandra as just having, it's a very highly available, highly scalable database. But there's certain characteristics of the data model that are particularly well suited to contextual data. And the data model that Cassandra uses is something called a wide column or a key value type store. And what it does is it groups a lot of data together that's relevant or contextually relevant to each other. And this is, as we go on, this is particularly suited to time series or event streams, because it will keep all the event streams and time series together in one partition. Now, the fastest way to query data is to pre-compute the joins. Now, that sounds a little fancy in terms of, well, you always do joins on multiple tables, but joins on multiple tables actually end up in real terms as a view. And what we want to say is, well, actually, to get the speed and the latency and the experience that you really require, you actually create the view first. And what we do in Cassandra, this is a typical relational data model in Cassandra, in a relational database like Oracle. Here you see a table, and it's basically showing us the events or interactions a customer has with our application by customer ID. You can see there's 3 customers here. One has an iOS device, another has an Android, and so on. And there's times associated with how much time they've spent on each page. But it's a difficult thing to conceptually see what is actually happening here. What Cassandra does is change the way this is actually stored. And what it does is it groups every interaction by each customer in a small table on its own. So this is like creating a view for each individual customer in the database pre-computed. So now I can see very simply, I can see the last page that customer 1 was on was the accounts page, for example. And I can also very easily see how long they spent on the balance page by subtracting the time of balance from the time in accounts. It's 17 seconds and so on. So now I can start to look at this customer and get a real-time view of how they're using the application. And similarly with customer 2 and 3 and 1 million and 10 million. So this type of structure is exceptionally well designed for really low latency, massive scale. And similarly, when new interactions come in, you can see there, as a new interaction comes in for customer 1, it's added to the top of the list. So I can always see the latest amount. So if I want to say, give me the last 10 interactions by this customer, now I can start to build a picture. And when we come into machine learning and AI, these are the types of queries that we will always be asking our data for. That's why Cassandra's data model and Cassandra is used in so many AI applications like feature stores and machine learning algorithm stores. And that data model also works for lots of other things like transactions within a loyalty program. So how many transactions are you doing? Where are you doing them? How are you doing them? And also messages. You may be doing messages between the customer and a retailer or an online chatter, like interacting all the time about different things. So there's lots of areas where the data model for Cassandra is perfect for today's challenges around these massive scale, massive interaction platforms. So that's how, when you think of this this profile here on the left of the Patrick Callahan and who he is and what he does, that's very easy to understand and create that view. Similarly to the recently viewed and the recently put in basket. All these are very simple data sets that come from the Cassandra data model that are perfect for this type of interaction. So just a little things outside the Cassandra ecosystem. One is Stargate. And Stargate is an API that sits on top of Apache Cassandra. It sits on top of the Astra DB, which is Cassandra as a service, and also the DataStax enterprise product that Mark will talk about in a few minutes. And what this does is it creates an API layer that you can use JSON or GraphQL, REST. You can also use gRPC to interact with the data that's inside of the database. And this obviously has huge implications to the teams that are using it. There's no more drivers to think about or upgrading drivers or deploying web apps. You can literally go from your front end to the database in one call. So it's become this very vibrant community that people are looking to just use APIs to get data. Give me an endpoint and I will tell you what I want and what format it's in. And this extends what we do in Cassandra, because in Cassandra and DataStax, we use 4 different models to hold your data. One is a column family, like we talked about with the Cassandra data model, perfect for those pre-computed joins and query-driven queries. But also you can use a document store, so you can hold JSON structures and search nested queries on those JSON structures. You also have key value for simple authentication or session management. And there's indexes that you can build on any relational type queries that you want to build. So, and all this is offered by the Stargate API as a facade or a layer above the database with all these different storage levels. So we're going to move on a little bit in a second to Mark's presentation, but I just wanted to show you a very quick overview of Astra. And as I mentioned in that view that we had about those microservices, we want to be able to use one place or one control plane where you can access data across all your clouds or all your infrastructure or all your deployments. And what Astra allows you to do is to create databases that are in AWS in any region. You can create databases in Azure or GCP, but actually manage them all in a very simple way through one control plane. And as I mentioned, each of these databases can actually be accessed through different APIs. So you can see here that the APIs for accessing this sensor time series is through document API. But you want to offer access through REST API to your partners. So all this is about agility and flexibility, but also that simple one place to manage and look after all your deployments. So I'll let Mark, if you want to talk about the clickstream in particular. We may come back to this at the very end.
Yeah, I mean, before we bring on Mark, I feel like this has been such a really interesting, use case, especially in the retail example. But I had a couple of questions for you, Patrick. I know you talked a little bit about low latency, massive scale applications, but besides like examples of retail, what other areas do you think, use cases do you think like a database like this would be best utilized for?
Yeah, so as I said, what we do, the Apache Cassandra has lots of characteristics. One is that data model, and that data model suits any data that's coming in, a structure of eventing, time series, but there's also characteristics around high availability or mission criticality. When you have systems that cannot go down, you want a system that both is always available, scalable in terms of what happens when you have peak times and things like that. But also then you can think about what we call multi-data center replication. How do I bring data to my customers? So if I have a deployment in the US, for example, how can I have data that resides both on the West Coast and the East Coast at the same time? Or similarly, how can I have data that resides in America and Europe at the same time? So these types of queries, especially around reference data, are coming up more and more. And then there's also the story of the clouds. How do I ensure that my data, my database and my data platforms are cloud agnostic? Because today I may be using AWS, but tomorrow I may be wanting to use IBM Cloud. And those are the kind of things that we want to make simpler through the DataStax platform.
Definitely. And then what would you say are like, you mentioned a couple of these things, but what would you say are like major factors when, enterprises and developers are considering to architect and build their applications, to consider data stacks, especially Apache Cassandra?
Yeah,
In
I think.
Yeah, go ahead.
Sorry, it comes down to a couple of different areas. One is, we are building, standardization for NoSQL. And one of the things that's happened recently is that, there's lots of data silos and there's a lot of different areas where, smaller, different types of databases have been used, and there's no standardization for an enterprise around NoSQL. And that's one of the things that we're bringing as DataStax. Another thing we're thinking about is lower total cost of ownership. A lot of the databases or legacy databases that we would think about are just too expensive for the applications that they're trying to build. We want fast time to market, and we want lower cost of ownership. But then from a use case point of view or an architecture point of view, we see data in three different ways. One is streaming data, which is data in motion. And then you have data, transactional data, that system of engagement where all the data comes together to make that contextual data platform that allows you to make real decisions. And then down the line, you have maybe the analytics piece, the kind of slower, smart data area. And that's where algorithms and deep learning and machine learning happens. But to use those in real time, they have to come back to the transactional system of engagement. That's where all the decisions, that's where the brain works. The brain learns in the deep layer, in the snowflakes and the DTs of the world, but they actually are used in the real world in real time. And that's what DataStax do better than anybody else, bringing data in context to make the best decision. And really what AI and ML is trying to achieve is those best decisions. How do I make a better decision than a person would? And how do I continuously learn if I'm making the right decisions? And all of that requires the data that we bring.
Definitely. And so I guess the last question I have for you before we bring on Mark, since you're from DataStax, could you talk a little bit about some of the resources that DataStax provides for people to kind of, get a deeper understanding of how to use the technologies there?
Yeah, sure. So there's two different areas. One is Astra, which is our online database as a service. You can sign up, you can get a free account, you can use it as much as you want. And then, that incorporates Stargate, which is this API framework, which allows you to use the tools that developers want to use, right? REST and APIs like GraphQL and so on. So the time to actually getting up and running is very, very small when you have a database as a service. The other side is the self-managed, and that's really about Apache Cassandra. It's DataStax Enterprise, and there's a little bit more handholding. You can deploy it yourself. You can start to run examples, tutorials, and we have a DataStax Academy. Like most software companies, we have an academy for tutorials that people can learn at their own pace.
Awesome. Yeah, so we actually have a whole, list of resources for you all. I think we posted a few in the chat, but happy to post that on the screen. I think we have some resources on the DataStax certificate as well as the DataStax Academy. So feel free to check those out. I think, thank you so much for your really in-depth example. I feel like now we want to kind of see what it's like in action. So I wanted to take this time to bring up Mark, and maybe we can see what this looks like in play. So, Mark, over to you.
Okay, thank you, Patrick. What I'll do now is, I think you're seeing my screen. So the code pattern that I worked on is called Capture Clickstream Data from your e-commerce website. And this is available on developer.ibm.com. With this audience, I can't, sit with you and help you through. But the way code patterns are written is the code is there in a public repo. The instructions are provided that really walk you through so that you can deploy and run and work with this database and run this app. In addition, our e-commerce website, it's a simple experimental website to do some clickstream data, but you'll have that code so you can play with that and extend it as you wish as well. So let me jump in and show you what we have here for you. So this is the web page for the code pattern. When we do code patterns, most of the information will be in the repo, but this will introduce it to you. So let me start here and show you. The basic flow is we have an application. You'll run the UI, and it's a Node.js app. I happen to be using Next.js with React components. And so as you click around this e-commerce website, it will be tracking clicks as you click pages or as you click on an add to cart component. The data is being fed to DataStax, and that's really what this code pattern is about, is having a DataStax or Apache Cassandra instance running. And for the code pattern, we focused on two things. One, we wanted to run it on OpenShift on AWS. The other is we're using IBM Cloud. And for that, I'm running locally, so I can run the app on my laptop and connect to the database in the cloud. So that's the database as a service. Now here, as you look at the hybrid cloud or database as a service options, we're using OpenShift. And in this case, I mentioned running on AWS. But the thing about OpenShift is I can run that on my laptop. I can run it on IBM Cloud, AWS, kind of any cloud or on-premise even. And OpenShift gives you that same look, that same ability to do things whichever cloud you're running on. So I'll go through how that looks on AWS, but it looks pretty much the same wherever you are, except maybe your storage options are a little different. As far as the IBM Cloud that's mentioned here, we have this database as a service on IBM Cloud, but I should mention Astra DB, as Patrick mentioned. They also have provided a database as a service on Astra DB, and this code pattern will work there as well. So I'll take a quick look at that as we get to it. So before I jump to the README, there's really three things that I want to do that I think I'll have time to get through here. One is show you how you can deploy DataStax Enterprise or Apache Cassandra on the cloud or on OpenShift. And that should be enough to get you going so you actually have it up and running wherever you need it to run. The next thing is interacting with the database. So once you get it running, you need to have a tool where you can interact, create tables, query tables, and we have instructions for how you would do that running in a OpenShift environment on AWS or running on IBM Cloud, and it's even easier on Astra DB, so I could show you that. And once you do that, you can get a feel for what you can and can't do with Cassandra, how you query it, what it shows you. It's really interesting to experiment and see how Cassandra or DSC is different than a legacy relational database. And the last thing is our application, our Node.js app, and interacting with the database. And that, again, the interaction is very simple, but what we want to do is make sure you have code and you have an example where you're using the driver to connect to the database wherever it is, and feeding those records and getting them out. So I'll jump to the README. This is from, if you go to get the code, we have a pretty thorough README that walks you through how to step through this application, get it up and running, and deploy it. So I already talked through the choices here, and really, whether you're running on a cluster or running database as a service, the key is, do you want it managed for you? And there are a lot of benefits to that. Or are you running on a cluster? And this cluster would be a perfect fit really for the way Cassandra works. It's already a cluster database, but now that it's really married to OpenShift and Kubernetes, as you scale your app, you can scale your database as well. So to get it up and running, I scroll down here to the deploying the database. And for the two different types of deployments that we focused on here, there are these two links. And I won't do that live, but I have enough information and screenshots that I'll give you a quick look at what it looks like to deploy with an operator on Kubernetes and OpenShift. And then the running on cloud is very simple. So if I look at the AWS instructions first, if you're not familiar with OpenShift, certainly first you'd need to get it up and running and get a feel for how to work with OpenShift and Kubernetes before you would attempt this. But once you're there, it's really simple. You'll have a login. So for OpenShift, OC is the command line. So you do your OC login. You create a project, which is like a Kubernetes namespace. So here, our e-commerce app is called bCommerce. So I set up a project called bCommerce. And what I want to do to deploy Cassandra is I'll use the operator. And this is really easy. There's one prereq, and it's clear when you use the operator, you'll see the instructions, but I've provided it here as well. And that's setting up the webhook. But once you have these YAML files, you've logged in, it's simply you run these commands so that the operator can work. And once you do that, the operator, I'm sorry if I'm scrolling too much. I sometimes hate that, but I want to show you where we're at in the code pattern. So once you do that, you're on OpenShift, running as administrator, you'll see Operator Hub, and you can go over here and search for all the DataStax operators. In my case, 2 of them came up for the Kubernetes operator for Apache Cassandra. Again, it's provided by DataStax, but you're getting Cassandra on Kubernetes. And it's really simple. You click the install button. I'm installing it on my specific namespace. Let me scroll down here. So I chose the stable version running on a specific namespace, and I chose that namespace I just created, the new project bCommerce. Using the manual approval strategy, I click install. It's really that easy, and soon you'll see your operator is installed. You get the green check mark. It's ready to use. Now that doesn't mean we have an instance of the database yet. That means the operator is ready to serve us. So once we have the operator, you can do a view operator, or as you're in OpenShift, this picture was actually running on my laptop. but it looks the same. You're an administrator, you look at the installed operators, there's a tab for Cassandra Data Center. You click on Create Cassandra Data Center. Now, the only option other than the defaults that I needed to pick here was the storage class. So if you're familiar with Kubernetes and OpenShift, you'll have storage classes and you can provision storage. Now, in this example, when I ran it on my cluster on AWS, I used this pull down to select a storage class. My cluster already had a storage class. I chose it. It was all automatic. The storage was provisioned, the database spun up, and it just worked. It can be that easy. In the case of running on my laptop, I was responsible for creating storage classes, provisioning storage, and once the storage is set up, then it just works. So that's more Kubernetes details than what we'll get into here. But the point that I'm trying to show here is it was really easy to use the operator hub to get the operator. Just create a Cassandra data center, select your storage, hit create, and it's up and running. Here are the instructions to watch it start up. So you can do your OC get pods. And what you'll see is this is the default. It's setting up cluster 1 DC1. It's showing you that it's trying to run 2 pods. The status is 1 was ready after a minute. Shortly after, they were both ready and running. Once your pods are running, you can connect to them. On OpenShift, again, with the OC command line, you can use OC RSH to tunnel into your nodes, similar to an SSH command. So here we do an example where we can remote shell into that pod and run node tool status to see what's running, what's up, and the details. I haven't done much with that command, but I think the node tool is very handy once you get into Cassandra and you want to see what your pods are doing, what your nodes are doing inside those pods. But more importantly, we're going to say you can remote shell onto a node to actually interact with the database. So in my examples here, for the database as a service and for running on Kubernetes, we have 2 different approaches to exposing your database to the world. So when I'm running on a cluster, by default, this database isn't exposed to the world, but if I remote shell onto that pod, now I can run SQL SH and I can interact with the database. So that's the approach I'm taking on OpenShift, and that kind of isolates your database within your namespace. And then we'll show you how to deploy the app in that namespace so the app can interact with the database. We're exposing the app to the world to do their shopping, but the database is still isolated. You don't have to do it that way, but that's a simple example, and I think a good example for using a database inside a cluster. For database as a service, we took a different approach. Again, you can have privacy options within IBM Cloud, but the first step I do there usually is I fire up that database on IBM Cloud, and I'm doing my development on my laptop. So I need that external endpoint, and that's what I'll use. And we'll show you how to interact with SQL SH or with the driver by running locally and connecting to that remote database. So to wrap up here on the OpenShift setup is what you get once you've used the operator to fire up the database is it has a secret with that super user password. And I show you here how to get the password, the username and password. And in the instructions for deploying the app on AWS, it suggests you just assign the secret to your workload. So it has the user and the password. But also you can look at them, you can connect, you can create your own users. But with a command like this, you're actually running SQL SH on your node, and you can start querying it. Here I just connect and I exit. But I'll switch over now to do the same. So this is SQL SH on OpenShift by tunneling in. And now I'll switch back to running database as a service and get you back to where we're doing SQL SH. Once we're in SQL SH, I'll look at some of the queries and commands to create tables and interact with them. So if I go back to deploying the database and I want to look at database as a service. Now here, there's not much to show really. If you're on IBM Cloud, if you search for databases, you'll see we have a variety of them, where there's Postgres, MongoDB, Redis, DataStax. You basically click on the one you want. Here, it's called Databases for DataStax, if you want to use DSE on IBM Cloud. So you click on that, and you just say create. I think the instructions are click on it and say create. You'll say really where you want it deployed, but you can take the defaults and it will spin up your database. The one thing in the instructions you should pay attention to is it wants you to set up your admin password first. So you'll do that. And once you do that, you have public endpoints and this secure bundle that you can download. So this is how you would interact like from my laptop or from a remote app to the database. The secure bundle gives you that TLS SSH connection to tunnel into your database securely. So you have that in combination with that username and password when you're doing your connection from remote. So how would you do that from your laptop? Well, you want to use the SQL SH tool. So that's what we had for free running on our node in Kubernetes. But to run locally and run on your laptop, you'll go here and you'll download it. And what's interesting, if you notice, if I go to IBM Cloud, let me see if I'm connected here. I think I am. When I spun one up on IBM Cloud, databases for DataStax, right away you have the getting started, and it tells you about the DataStax drivers to connect an external application. It tells you about Node Tool and Node Sync. And I think if I go down here, oh, I missed it, but it will tell you about setting up SQL SH. I don't want to search too much. Getting started, you'll download the bundle, and we'll have links. Basically, the link is going to take you here, and that's what I walk you through in the code pattern. When you click on this, you'll see it goes right to downloadsdatastax.com to download the SQL SH tool. And here you'll see you pick which version you need. You click on download. You simply expand it and run it. So let me jump to that tool. Well, let me jump back to the README first. So now we have the tool. So I downloaded and expanded it, and I'll show you where I run it. Oh, I should show you one more thing. Sorry. So I showed you can just remote shell and use the username password when you're on Kubernetes. What we'll do when we're on the cloud is after you unzip the download, I run it from wherever I downloaded it. You put it in your path. Use your admin user, your admin password, or create additional users and password. But that secure bundle download is very important for this. That's this -B option. And then that actual download file, that .zip file. That's what I'll be using. So here you see I'm running SQL SH. This is on my laptop. I have a key space. I'm connected. Okay. So this is running on my laptop connecting to, I believe, IBM Cloud. I have a connection to Astra here as well. Oh, I did. It timed out. Just a second. If you're using Astra, again, it's a database in the cloud. It's managed for you. In this case, I created a key space already. So I can go in and look at my key space. And if you look at the tabs here, you can run your SQL console right here. I think I already have data here. Use key space. I called it KS1. So there's the data that I had on Astra. And so again, access to a console is very important. So now you have access to a console, whether you're running on OpenShift, you just a remote shell and run SQL.sh with that user and password. If you're on IBM Cloud, you can download SQL.sh and run it on your laptop with that secure bundle, user and password. On Astra DB, you have SQL.sh right here in a tab. So you can create tables and query, and that's what we'll do in just a minute. The other thing that's interesting here is if you go to connect, you'll see a lot of documentation like the APIs, for example, but also Node.js is the one that we're using. And it describes to you, download your secure bundle, very much the same on Astra DB as it is on IBM Cloud. When I'm on IBM Cloud, we'll use the username and password along with the secure bundle. But here with Astra, there's a tip right here. Your username is that client ID, and your password is the secret, your app token secret. So you get your connection information right here in Astra DB, and it all works very much the same way. So we'll work with the app we're providing, and you can also use it for the SQL examples. So let's take a look at those examples. So once you're up and running, so now you have a database deployed somewhere. You have SQL.sh that you know how to get at and connect. So here are some examples to get you started with Cassandra or DSE. And I find it interesting because it's not your legacy relational database. There are some things that are different that are required that help it do what it's really good at. So the first thing is, in Cassandra, you work with a key space. So we'll have to create a key space to use. So I will copy paste this, move it to the side here. I already had a KS1. Let me create one. So create if it doesn't exist, demo. And you're required to give it a replication clause here. And everything ends with a semicolon, so it knows you're done. So I created a demo key space, and for replication, you have different strategies for how to spread around the replication, and a replication factor. That's like how many copies of the data do you want? So this is not optional. You will replicate the data. That's how Cassandra works. That's by design to make it resilient and also make it scalable. So now I have a key space. Once you have a key space, I was using KS1 like in my examples, but I can say use demo. So I'm in that key space. There's no clickstream data yet. So I'm trying to navigate my screens a little bit. So the first thing we want to do is create tables. And here, again, the examples help you get your hands-on experience working with the database, but also links like this, they jump to the documentation, and you notice this is DataStax documentation, and it does a very good job of explaining what the syntax is. It's not quite standard SQL, but it will look very familiar, and tells you things that are important to Cassandra, like a table must have a primary key. So in my examples, I go through some of these things. Let's go ahead and create the table. So here's one example. In this case, the primary key is simply on this column. And I can do by the way, I could say ks1.product to query that table, but without giving a namespace, it's using the one that I said use. I said use demo. So one thing that's interesting here is I had to have a primary key, and the color actually tells me which one the primary key is. The second example in the documentation is the other way to specify primary keys. In the first example, the primary key was put right on the column definition for product. You can do that if it's a simple primary key on a column, but you can also do more complicated primary keys. So here it's on plant and product. And here you notice with the coloring and with the parentheses, there's two parts to the primary key. So there's the partitioning key, and there's also a uniqueness. So this is saying that the partitioning is going to happen based on plant, but the uniqueness is a bigger key than that. So you have a multi-part key, and inside these parentheses, by the way, you could have more columns here that are part of the partitioning, and you can have more columns that are part of the key as the unique identifier. So the next thing I wanted to do is show you a couple things. Well, maybe just one thing here. Yeah. Let me switch back to the README. So if we look at the README, you can get a few examples. I can go a little more quickly this way. But one thing that was interesting, if we want to insert or update some data. So you might be familiar with the term upsert that some databases support, some don't. So in your old legacy relational database, you would insert a row. If you don't have a primary key, it's like an add. If you have this uniqueness constraints, then it would fail if it already exists. If it doesn't exist, it would insert it. So if it already existed, then you'd fail and turn around and do your update. So Cassandra not only supports upsert, but it's the default. That's how it works. And that's because everything's required to have a key, so it just makes sense that way. So you can do an update, or you can do an insert. It will find that row by that key, and it will update it. If you really want to check for existing, you can use insert and say only insert it if it doesn't already exist. So that's a little bit different than legacy relational databases, but it's a really great feature. And it also emphasizes that with Cassandra, you will have some requirements. You cannot create a table without that key. It requires that key. It requires a partitioning key. And once it has that, it understands things like, well, now I know everything's uniquely identified, so I can use that with inserts and updates. And that's important not only for the integrity of that table, but remember, it's got replication to consider as well. So it needs to make sure that the replicas are consistent, and that helps it do what it's good at. The last thing I was going to show here is using batches. We're not doing a lot with that, but I thought one of the things, again, interesting, and if you link to the DataStax documentation, as I have links here, you'll see some advice on using batch. So for example, you can batch commands together, right? That's great. Don't do 2 round trips when you can do 1. But notice the advice here. When you're using batches, you can reduce the latency by doing 1 instead of 2, like an atomic transaction. But for performance reasons, never do batches across partitions. Again, it's Cassandra, it's replicated, it scales well, but you want to be aware of what you're doing. So you don't want to say, hey, insert some records distributed across this cluster, some here, some there, and then sync it all up, make sure it's good, and get back to me. You want to do your batches that make sense, but then you can do it. So if you have that consistent partitioning key, go ahead and batch your queries, send them to Cassandra. And last, let's create the table that we'll use in the example app. This example, you'll see First, create if not exists. I'm actually using that in the app because I'm lazy, so it will automatically try to create this table, but it exists, so it won't. A variety of columns for clickstream data. And the primary key for partitioning, I'm partitioning on every customer ID and click event type. So it's very partitioned. I haven't done a lot of scalability testing, but my goal was let's spread things out so we can just add nodes, add nodes, add nodes. And also part of the key is the timestamp for the uniqueness of these clicks. And again, if I do a select star from clickstream, it's empty. And again, I really like this where the coloring shows you the keys. Now if I go to my app, first let me show you where we're at in the code pattern. So I've walked you through these queries and getting a feel for Cassandra. Now let's run this little app that actually tests it out. So we configure the app, and basically you need to have environment variables. So running locally, we typically use a .env file. So we have to say where the bundle is, the secure bundle, username, password, and optionally a key space. And if you're on OpenShift, it's very similar, but we do it with config maps and secrets. So the instructions are here. But once I'm configured and I already have my .env file set up, I will just run the app and click around and see what happens. So let me jump to that. So here in my other screen, see, actually I was trying to connect a demo earlier because that's the key space I have configured in my .env file. Now if I run it again, I'll just run in dev mode. Come up pretty fast. So I'll have some logging here that might be interesting. It's trying to create the table because I was lazy, but it already exists. And it looks like someone's already browsing. That must be me. Yep, it's connected. So this little app, I apologize. I don't like this masks and sanitizer theme anymore, but it's carried over from a different code pattern we had for inventory and decision optimization. But for e-commerce, I added a little bit. I don't apologize for the B swag. I'm a fan of the IBM gear. So we have a little website, and the use case, the story is you create an e-commerce site, it blew up, you need to scale, and you want clickstream data to know what your customers are doing. Like in Patrick's example, let's be smart and know what's going on our website. So I added a few things. I added the B swag, I've got my masks, and I added essentials. Now this is Next.js React app. First thing I want to do for clickstream, you see it's tracking my clicks as we go. Customer ID 0 is what I'm using when I haven't logged in for convenience, but I have a simple sign in here where you don't really need a user ID. I'll just say AAA. But once you get a user ID, it gives you a cart ID just based on that name. So 656565. And you'll notice it's already tracking my clicks. It already knows that I'm browsing the home page. This is a server-side rendered page with Next.js. So if I click on Essentials, again, as soon as it rendered this page, it sent a record to Cassandra, and you saw now I'm browsing Essentials. Now, if I click on one of these, let's say I want to add to cart a little bit of wine, maybe some toilet paper, and maybe some more wine. Maybe more wine. It's tracking every click, and if you're interested in the UI end, again, server-side rendering is used for the page, but these are React components, so the client side is actually calling an API to record these clicks. But once it gets to the server, it's very much the same. It's simply inserting these clicks, and tracking what we do. The last thing I think I want to show is, so now we know we can click and we can see. Oh, let's query it. Lost my screen. So this was the demo namespace that I think I'm using on the cloud. I think I'm using, and sure enough, now we're tracking. User 656565 was adding to cart toilet paper and wine and browsing BSwag and essentials. So this is user 0. The last thing we did, and it's really not filled out yet, we're saying, okay, so this is tracking clicks. We're running on AWS with OpenShift. We're doing Cassandra. If this blows up and now we've got way more customers than ever, I mean, this stuff was implemented by Facebook originally, right? It'll scale. Add node, add node, add node. We can keep adding customers, keep clicking, keep scaling, just keep adding nodes. And that's the whole design of this fast write, super scalable database. But the last thing we added is, how do we make this smart? So certainly on the back end, we can be using this clickstream, doing some analysis, doing some AI. That's great. But what if all the clients are also doing that? So I haven't done much with it, but it's in the code base here that you can play with. I added the page is very raw. If you just go to history, now I'm actually querying my own 656565 clickstream history to see what I'm doing. And I left it raw so you can see what host it's using out of my DataStax cluster. It gives you all the clicks. It also describes information about the schema. So that's the raw output. This is actually, since it's raw, I can go right to my API. Oh, I have it here. I'm still allowing you to query any user you want. So I could say, if I'm client 0, I'm constantly querying this to see what's going on with client 0. If I'm client 656565, I can query this. And one thing you'll notice, it queried this host 207. And now it's querying this other host. So I have a simple connection. I just gave it a service ID. Well, you give it one connection. But as you're adding nodes, Cassandra is still balancing the work. So whether I'm doing that fast right across the cluster, the data is partitioned, so the work's all spread out, but also it's handling all that, deciding where to send the work. Querying as well, it'll spread it out to the different nodes. So it's built to scale in that sense.
This is really cool, Mark. Thanks. It's such a really interesting example of, this database. And I know that you were able to get it all running, and you have I guess your code pattern had some really great insight on how to kind of get started. But the last question I have before we kind of end this call, it's been a great call so far, is, what do you think? I know you have this running with OpenShift. So why can you talk a little bit about like OpenShift and benefits of using the DBs on there? I know that it's great. Yeah, go ahead.
No, no, definitely. And so first of all, having the database managed as a service, it has great benefits, right? And one thing I showed you the how simple it is on Astra. It just provides it for you. One of the things, again, I wasn't navigating this very well, but yeah, I forgot to mention this. Notice my instance here on IBM Cloud, it actually took a backup for me 2 hours ago. I didn't think about that. I just clicked the button and got a database. It's doing things for me. It installed it. It provisioned storage, is backing it up. So a managed database does a lot for you. But ultimately, you're an e-commerce app. There's a good chance you're going to want a cluster to scale your app as well as your database. And that's where I think running this on OpenShift is, is your ultimate cloud native architecture, because then you can do it on IBM Cloud as well with the database as a service. for the example I have here, if you're willing to manage your database, manage your storage, manage your backups, it was so easy to get started. I used the operator. I deployed Cassandra, multiple nodes. I have instructions here on deploying the app the same way. So it's in that namespace, multiple nodes interacting with the database. So now with OpenShift, what do I have? It's hybrid cloud. So I can do that the same way on AWS, Azure, IBM Cloud, on-premise. I've run it on my laptop with code-ready containers. It's just OpenShift. And you have all that power that you get with OpenShift and Kubernetes for scalability. Mm-hmm. But now with Cassandra and DSC, you're looking at this perfect marriage. I mean, it was written before Kubernetes, but it always had this cluster scalability concept built in. And in the more recent releases, it's very much written for Cassandra, written for Kubernetes, and it builds on that. So it's the perfect fit for cloud native scalability, where I start to have thousands of customers and I need tens or hundreds of nodes. You just add nodes, not just to your application, not just your front end, not just your back end, but also that database. That was not easy to do with relational databases with the legacy ones, not at all. So now it's just click, 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 expand, expand, expand. And the other thing is, you notice some of the restrictions and keys that they do to help make that work. Well, it's built with this scalability and replication in mind. It's not an option. You will replicate and it will do it well. So, so I think it's a perfect fit for OpenShift and hybrid cloud and highly scalable applications.
Awesome. Well, thank you so much, both of you. I feel like we went through so much content today, and Mark, you gave such a really great use case. I just wanted to pull up this just for any one of you who are have been following along and are interested in some of the things that both Mark and Patrick talked about. So if you're interested in the code pattern that Mark went through, feel free to check out developer.ibm.com. You can check out the code pattern there, as well as any of the resources such as like the DataStax Academy, as well as the DataStax certifications, and any content that you're interested in checking out involving DataStax. And I believe you can also take an exam as well. And we also have a free OpenShift cluster available for anyone who is interested in playing around with OpenShift, as well as a free IBM Cloud Essentials course. So I recommend anyone to check out some of those resources as well. So Patrick, any last words? This has been really great.
This has been great. I learned a lot from Mark in the half an hour. I mean, but one of the things that is so critical nowadays is that we scale our data with our applications. I think, Mark, you said it perfectly. Scaling your applications with microservices and Kubernetes has always been pretty easy because they're stateless, but they have to go hand in hand with the data that they're working on, and to be able to move applications from AWS to IBM Cloud or through OpenShift, you want the data to move with it. You don't want to create gaps between your data. So the data and applications should be flexible enough to both scale and to move as easily as we can with OpenShift. So really great to learn more about that, Mark. Thank you.
Yeah, sure. Thank you both for joining us.
Yeah. It's great to work with you. And yeah, I worked with old databases where we had to duplicate them on multiple physical hardware and string them together and make it all work. To be able to just distribute and click and scale like this, it's great to play with this product. So I hope everyone gets a chance hands-on to try it and see how it fits your use case.
Definitely.
Thank you.
This has been an awesome session. We've learned so much. We also have both Mark and Patrick's socials on the gist, so feel free to reach out and follow us on Developer to keep up with some of the other content that we have coming up. So thank you both. This has been an awesome session. Have a great one, everyone. All right.
Much appreciated. Bye.
Bye-bye.
Thank you.